All right. Hello, my gems. Today we are going to talk about our next section within trigonometry, which is called the law of sines and the law of cosines. So prior to this, we have practiced using trig ratios to find side lengths and angle measures in right triangles. So we've only done right triangles up until this point. We've done sine, cosine, tangent, and we've talked about the inverse when we're looking for angles, and we've talked about using those regular trig ratios when we're finding our side lengths. Now, sometimes you are going to have triangles that are not right triangles. And the only way to figure out the side lengths or angle measures of those right triangles is to use something called the law of sines and the law of cosines. We're not allowed to use regular trig because that only works with right triangles. So the law of sines shows the proportional relationship between angles and their opposite sides. It can be used to find side lengths and angle measurements for any triangle. So again, does not just have to be a right triangle. It can be any triangle at all. So the law of sines is proportional, and it shows a multiple proportions that have a relationship between the angles and their sides. So if we take a look at our picture here, the uppercase A, B, and C are the vertices. And so those are the angle measures, right? Angle A, angle B, and angle C. The sides that are across from those angle measures directly opposite are the sides that essentially match up with those angles, right? So side C, if we go across, matches with the lowercase side C. Angle A matches with lowercase a, and angle B matches with the lowercase b, side B. So the proportional relationship is as follows. If you take one of the angle measures of one of the triangles, so angle A, and you take the sine or the sine trig function of that angle, and you divide it by the side that is opposite that angle, that should be proportional for all sides of the triangle. So in other words, I can write it like this. The sine of angle A divided by side A. So that's my first proportion. It should be equal for all three proportions on of all of the triangle. So angle B, if I go across from angle B, that would be side length lowercase b. So this is proportional to the sine of B over lowercase b, which is also proportional to angle C, which again, if we go across from angle C, we get side C over here. So it's sine of capital C over C. So this is a proportional relationship, and it holds true for all triangles. And we're going to use this to help us solve for side lengths and for angle measures within different triangles. So part one is finding missing side lengths using the law of sines. So if we take a look at example one, we are looking for this side over here, side X. If I go directly across from side X, the angle that matches up with side X is angle 71 degrees. So my first proportion is going to be the sine of 71 degrees, right? So sine of the angle over the side length is X. Now, this should be equal to the other side in angle proportion or fraction that I have listed there. So I also know that this is side 12 over here, and the angle that it matches with is angle 35. So my fraction is the sine of 35 degrees over 12. And now what I have here is a proportion, and we are allowed to solve proportions by doing cross multiplication. So we're going to do a little bit of multiplying diagonally here. So X times the sine of 35 is sine of 35 times X equals, and then I cross multiply the other way, sine of 71 times 12 is sine of 71 times 12. Now, this is an algebra problem, and I want to get X by itself. So in order to get X alone, this right here is multiplication. So I'm going to do the opposite, which is divide by sine of 35 on both sides. So whatever I do to one side of the equation, I have to do to the other side of the equation. Okay, so it'll cancel over here, and this part I'm just going to now plug into my calculator. Now, when I plug it into my calculator, I'm going to go in the following order because my calculator is kind of backwards. So I'm going to do 71 sine times 12 equals, let me get a decimal, and then from there, I'm going to take that decimal, I'm going to divide by 35 sine equals. And when I do that, I get 19.8. So this side length right here is 19.8. Now we're done. So there we use the law of sines to help us find a side length. We're going to do the same thing now for example 2. Okay, side that I want to know is this side over here, side x. Okay, so this is what I'm looking for. And if I go directly across, the angle is this angle down here at the bottom on the right. Now, I've got a little bit of an issue because the angle that's directly across from the side does not have anything there. I do, however, know that this angle is 29 and this angle is 103. And I know that this is a triangle. A triangle always adds up to be 180 degrees. So I can figure out that unknown angle by taking 180 and subtracting the two other angles that I have, which are 29 and 103. So if I subtract them both from 180, I get 48 degrees. So this angle here is 48. So one of my fractions is going to be the sine of 48 over x. So it's the sine of the angle over the side across from it. And now again, I go, okay, which side length am I given? I'm given this side over here, which is 15. And the angle that is directly across from it is the 29. So my second equation becomes sine of 29 degrees over 15. And again, I'm going to cross multiply and solve for x. So my first one is sine of 29 times x equals, cross multiply again, the sine of 48 times 15. And now I want to get x by itself. So in order to do that, I'm going to divide by the sine of 29 on both sides. And then from here, I just plug it into my calculator. And when I do that, I get x is about 23. So this side length x is approximately 23 units. Okay, part 2. We're still going to continue using law of sines, but this time we're going to find missing angles using the law of sine. So our setup is still going to remain the same. I'm still going to start by identifying, okay, what is it that I'm looking for? So I'm looking for angle x right here. Now, the side length that is opposite angle x is this side over here, 37. So my first proportion that I'm going to write is going to be the sine of x over 37. There's my first fraction. I'm going to write another fraction for the other piece that I know. I know angle 94, and I know across from the 94 is the 43. So my second fraction is going to be sine of 94 over 43. Now, just like before, we're going to cross multiply. So notice nothing's really changing here. So I've got the sine of 94 degrees times 37 equals the sine of x times 43. Now, I want to get, again, the x by itself. So one of the things that I have to move over, because I see the x is here, it's with the sign, so I have to keep it with the sign, but I can't get rid of this times 43. And so to get rid of it, I'm going to divide both sides by 43. Okay, now I'm going to plug that into my calculator. So sine of 94 times 37 and then divided by 43, I get 0.8584 is equal to the sine of x. Now, in the past, because we are looking for an angle measure, we're trying to get x by itself, right? In order to do that, what I'm going to do is I'm going to get rid of the sine by taking the inverse sine, because again, we're looking for an angle measure. So now I'm going to take the inverse sine of that decimal that I just got, 0.8584, and that's going to give me my angle measure. So leaving that entire decimal in my calculator, I'm now just going to push shift sine, and I get that my answer is about 59 degrees. Okay. And one more, again, law of sines, trying to find an angle measure. So I'm looking for angle X right here. And across from angle X is my 7. So my first fraction is going to be sine of X over 7. And then my second angle I know is 82, and across from it is 18. So my second fraction is sine of 82 over 18. And now from here, it's going to be cross multiplying. So sine of 82 degrees times 7 equals sine of X times 18. I want to get the X by itself, so I divide both sides by 18. I plug 82, the sine of 82 times 7 divided by 18 into my calculator, and I get 0.3851. And because I'm looking for an angle measure, I'm going to now use the inverse sine of that angle. So keeping that in my calculator, I pushed shift sine or inverse sine, and I get X is about 22.7 degrees. So there we have used the law of sines to create two proportions, cross multiply, and help us solve for either unknown sides or unknown angles in any triangle given. Now, next part is called the law of cosines. The law, just like the law of sines, can be used to find side lengths and angle measures in any triangle. Now, given this triangle, ABC, here's what happens. In order to find the length right here of this side, so if I was asking you what is the length of side A, what you would do is this. You would say, okay, A squared equals, so this is the side I'm looking for. The equation is you take the other two sides that are not the one you're looking for, right? So if I'm looking for A, I'm going to take B and C, and what I'm going to do is I'm going to square them and add them together. B squared plus C squared minus 2 times BC, again, those two sides that are not the ones you're looking for, times cosine of angle A. And so you're going to pick the angle that is across from the side that you're looking for, just like with our law of sines. The same idea goes for the other two sides. So if I was looking for this side B right here, if I'm this time looking for side length B, the equation looks like this. B squared equals, I take the two sides that I'm not using, C squared and A squared, and I add them together, minus 2CA. So again, the two sides that I didn't use, times cosine of B, because B, capital B, this one, is across from my side length. I'm sure you can probably figure out the last one, but if I were to try to figure out side length C, my equation is C squared equals A squared plus B squared minus 2AB times the cosine of C. So really what matters here is no matter what one you're looking for, your equation always is whichever one you're looking for goes on the outside, and then the ones that you know, the other two side lengths would be the other two like variables that are left over. Okay, so let's find a missing side length using the law of cosines. Okay, so this time I'm trying to look for this side right here. Okay, this is my unknown variable, my unknown side. And the angle that matches up with it that's directly opposite is this angle 52. So these go together. So here's how I'm going to write our equation. This is my unknown, so that goes on the outside of my equation, x squared equals. I now take the other two side lengths of the triangle, 23 and 30. The order doesn't matter. I add them together, squaring them. Minus 2 times these two sides again, 2 times 23 times 30, and then times the cosine of my angle that is across from the side I'm looking for, and my angle is 52 degrees. Okay, now this is just an algebra problem. Maybe it doesn't look like it, but it's just algebra. You're trying to solve on the right here and get x squared all by itself. So you're going to do, excuse me, some order of operations. So first and foremost, let's do our, there's really no parentheses. So what we're going to do is our exponents. So 23 squared is 529 plus 30 squared is 900 minus, now this is just multiplication, so I'm going to multiply these numbers right here. So 2 times 23 times 30 equals 1,380 times the cosine of 52. So far all I did was do those squared numbers and then multiply. Now, I can combine, excuse me, so like terms. On the right, I definitely see just some regular addition here. So I'm going to combine together the 529 and the 900 to get 1429. And then I'm going to bring down everything else. Minus 1380 times the cosine of 52. Now, from here, I've got just essentially it's subtraction. It's this number minus this whole thing. So what I'm going to do now is I'm going to take this entire equation and I'm going to put it into my calculator to see what I get. Minus. So I'm now going to put this into my calculator. So I'm going to push 52 cosine and then times 1,380. I get 849.61. Okay. My next step is to just subtract these two numbers. So I get x squared equals 579.39. And then my final step to get x alone, because this is squared, the opposite of squaring something is to square root. So I square root, and I get that x is about 24.1. So the length of this side of this triangle is about 24.1 units. All right, one more. Excuse me. This time we're going to find a missing angle using the law of cosine. Okay, so we're still going to set it up the same way. This time I'm looking for angle X, and the side that directly is across or opposite from it is this side 35 over here. Okay, so now when I go to write my equation, the first thing that comes is always the side length, either that you're looking for, or it's the side length that is across from the angle that you're looking for. So since we're looking for an angle this time, across from that is the 35. That's the number that goes on the outside of my equation. Okay, 35 squared equals, I now take the other two sides that I have of the triangle, 16 and 24, and I plug them in, 16 squared plus 24 squared, minus 2 times those same sides. So 2 times 16 times 24, and then times the cosine of our angle, and we don't know what our angle is, so it's cosine of x. Now again, this is an algebra problem, so I'm going to start with order of operations. I'm going to start by squaring, oh my goodness, the numbers. So 16 squared is 256, plus 24 squared is 576, minus 2 times 16 times 24 is 768, times the cosine of x. And my next step is now I'm going to combine some like terms here. So I'm going to put together the 256 and the 576. And I get 832. Bring down everything else, minus 768 times cosine of x. And now I'm trying to get this x by itself. So this is multiplication. So I'm going to leave this alone for right now. I'm just going to move the 832 over to the other side. And in order to do that, because this is a positive 832, I'm going to subtract 832. So I'm up 393 equals negative 768 times cosine of x. Okay. Still trying to get cosine of x alone. So in order to do that, I need to get rid of this negative 768. Now, this is multiplication. So to get rid of that, I'm going to divide by negative 768. Over here, I get negative 0.5117 equals cosine of x. And now because I want to get x alone, I have to take the inverse cosine so that I can find an angle measure. So I'm going to take the inverse cosine of that decimal I just got. And when I do that, I get x is about 120.8 degrees. So this angle here is about 120 or 121 degrees, depending on how you want to round it. Okay, beautiful. Last problem, an application problem. So now we're going to have to use our laws of sine and or cosines here to help us solve for this problem. Okay, so this problem says, to measure the height of a hill, a woman measures the angle of elevation to the top of the hill to be 24 degrees. She then moves back 200 feet and measures the angle of elevation to be 22 degrees. Find the height of the hill. Round your answer to the nearest tenth. Okay, so we have our woman who started at this point right here, and her elevation is 24 degrees. Remember, elevation means you're taking your head, you're tilting it upwards, you're physically elevating your head. Then she steps back 200 feet, and then her second angle is at 22 degrees. Now, we've got two different pictures in this problem. Well, really three. You've got this smaller triangle over here on the left, which is definitely not a right triangle. You've got the right triangle on the right side, and then you've got the really big triangle kind of encompassing everything here. So what we're going to do is we're going to look at them as individual triangles. Whoa. Okay. So first thing I want to figure out is just what this side length is right here, because I already know I'm going to need this side length in order to figure out what this height is, because you need two different sides in order to figure out your third one. So I'm going to start by solving for this side right here. And by doing that, right, this is a shared side. They have it in common. So if I solve it for one, it better be the same in the other one. Okay, so I'm going to put my X there. Now, in this triangle, you do know that this angle right here is 22 degrees. You also can figure out this angle right here because this kind of green angle and this 24 degrees make a linear pair. So to figure out this angle in green, I'm going to take 180 and subtract the 24, and I get 156 degrees. So I now know this is 156. And I also can figure out this angle up top, which I'll color here in orange kind of, by again saying this is now a triangle. So if I already know that a triangle is 180, I can figure this out by doing 180 minus the 22 and the 156. And when I do that, I get 2 degrees. So this angle here is worth 2 degrees. Okay. So I now have this kind of like funky triangle, and I'm just going to redraw it. So that it's a little nicer to see. Okay, here's what that triangle looks like on the left there. And I'm trying to figure out this side length here because that is my shared side. Okay, so if I am trying to look for this pink side, the angle that's opposite that side is the 22 degrees. So I already have one side length. And I can actually do it a second time because I also have this side is 200 and the angle across from it is 2 degrees. So I'm going to use the law of sines here to help me solve for this side length over here. So what I'm going to do is this. I'm going to take the sine of 22 over the side that it has across from it is the x equals the sine of 2 degrees over 200, right? Because that's the side length, and then that's the angle that was given to me. Okay, now I'm going to cross multiply. And then my final step to get x by itself is I'm going to divide both sides by sine of 2. Okay, and now this just becomes a problem for my calculator. So let's see. So when I do that, I get that side x is 2,146.77 feet. Okay, so if I come back to my picture here, that is this side right here. That's the x. So now I know this side, and I'm trying to figure out this height over here. So now I have a right triangle right here. So now if I come over here, here's my right triangle. I know the shared side, I just figured it out. That shared side is 2,146.77 feet. I know this is a 90. I'm trying to figure out my height, and I know this angle here is 24 degrees. Now, you could, if you wanted to, try to do law of sines or cosines, but because this is a right triangle, I already know, hey, I'm allowed to use trigonometry. I'm allowed to use SOHCAHTOA to help me solve for the unknown side length here. So knowing that, if 24 is my reference angle, H is my opposite side, and the 2000 number, that is my height or my hypotenuse side. So if I want to use opposite and hypotenuse, I'm going to use sine. So my sine ratio is sine of 24 degrees equals opposite over hypotenuse, which is h over 2,146.77. So op over height. Okay. This now becomes a 1 underneath, and I cross multiply. So all I have to do is multiply sine of 24 times that really big number times, and I get that h equals 873.2 feet for my height. So the height of my triangle is 873.2 feet. So notice how we did both law of sines and trigonometry within the same problem. Remember, trig only gets used with right triangles, but law of sines and cosines get used for all other triangles that are not right triangles. Because if it's right, you might as well use some trigonometry. Okay, from now you've got some practice problems to complete on Canvas, and then you also have some IXLs to complete as well. Hopefully this helped you out, and that's all I got for you today, my gems. So have a wonderful and amazing day, and that's it.